Hello everyone. So now we are going to see how to make a basic schematic in the custom compiler. So let's get started. I have already invoked my custom compiler, and in the last session we created one library by the name of com_ckt. Now we will be making the schematic of an inverter. So let's see. So I already have my library. So what I'm going to do is I will go to file, I will go to new, and from here I will select cell. And after selecting cell, so just make sure that the library in which you want to make your cell, that is being selected here. So right now com_ckt has been selected, right? If you see here, and now I will give the name of my cell. So I want to create an inverter, so I'll just give a name inverter here. Okay, and I will just do the apply. So if you see the here we have libraries, here we have the cell name. Now once we have created the cell, I will be creating its view. So when it comes to VLSI industry, we can have the different views like schematic view, layout view, config view. What we're going to do is we have to create a view. Since we want to create a schematic, so we will be selecting the schematic view. So let's see how to do it. Again, I will go to file, I will go to new, and I will say cell view, and I will click onto the cell view. Now, if you see in the library section, com_ckt has been selected, cell inverter has been selected, and view. So, what we are going to do? Cell name, we know inverter. View, for view name, if you see, if you click on the drop down here, it will show you all the different views it could create for you, right? So we could create a Verilog A, Verilog, all these views could be created. So since we are discussing here, so we will be doing the schematic view since we want to make a schematic. So I'll click here. And since I have selected the view name as schematic, it will automatically take schematic editor here. If you see, you also have the different types of editor, right? Layout editor, hierarchy editor, right? So we want to create schematic. For schematic, we will be selecting schematic editor and open on create. So now I will just click OK. Once I do that, I get a schematic window over here. If you see over here, it is written as inverter schematic, right? Now we want to create our schematic. So what is the first process of doing it? So basically you have different tabs here, right? So you should explore them. So tools, design, view, add, edit, check, options, utilities, windows, and help, right? So I will just go to the add. I will just select this instance, right? Now, if you see in front of this instance, there is a letter which is written I. We call this as a hotkey, right? So you can add anything by clicking on this instance like this. Now I clicked on the instance. Now I want to create an inverter, and I want to create this inverter on a so I want to create an inverter. So that means I will be needing an NMOS and PMOS, and I have associated this library with the reference 40 nanometer, right? So I will be taking the NMOS or a PMOS or any device whichever I want in my circuit from that particular library. So I'll go library, I will select reference 40 nanometer cell. So if you see, these are all the cells which it has. Now it has got two NMOSs, N_40 and NH_40, right? So N_40 is a device which will work on a supply voltage of 0.9 volt. NH_40 is a device that will work onto the 2.5 volt. So now what we will do, we will select N_40, right? So now if you see, it is coming here, right? So I'll just select here, and I will select P underscore 4D. So now my PMOS is coming, right? Yes. Now, if you see, when you have called this cell, over here, there are parameters, right? So it is saying it's a SPICE model. Okay, in the LBS model, this name is also P. The width per finger, the total width is given, the length is given, right? Number of fingers. Now, what are these parameters? We can talk it about it later. Right now, we are just trying to create an inverter schematic. So let's do this. So I'll just hide this, right? Now, if you have this extra device which is coming, just press escape. Now, what you can do, if you, so we want to connect. So we know when it comes to an inverter, right? So there's a drain, gate, source and bulk, right? So how do I know which this terminal is? Click over here, yeah, and I press Q. I click this node and then I press Q. So it will tell me this is the drain of my PMOS, right? Similarly, if I click onto this node and then I press Q, then it is telling me this is a source of PMOS, right? So this is the way you could check about your source and drain. So now we know in an inverter, the drain of an NMOS and the drain of a PMOS, they are connected. So let me just click over here and just show you. This is also the drain of my NMOS. You can see, right? Name, direction, input, output, net name is net1, right? So now what I'm going to do, now again I want to connect them, I need a wire. So to have that wire, I will again go to add and I will click onto wire. Okay, and this is the short key. So when you have a short key, you do not have to go to the edge. So it's like this. Now, right now I am on the editor window and I want a wire. So what I'm going to do is I will just press W from the keyboard, right? I've pressed W and now I'll be able to see this wire. Okay. So short key is just to help you, so you do not have to every time go to add and do it, right? So the gate of an NMOS and the gate of PMOS needs to be connected. This needs to be connected. So I'm taking out some extra wire here. Now, now that we have connected these wires, we are not going to make the simulation setup here. Okay, for making the simulation setup, we will be using what is known as a symbol. Right now, I know that for an inverter, I also have pins, right? So now I want to add those pins. So what I can add? So to add pins, so if I go to add and I see pin, so the short key for the pins is P. So I'll just select pins. Now in here over the rim, I could see pin. So name. So I will say, okay, let me give it the name in, right? And you have mode single pin array by region type. So I want to have a single select mode as a single pin, type as input, and I will just connect it over here. Now I will also click out. Okay, and this is my output pin. So I have to change this name, right? Now it is coming in this direction. If I want to change it, then I can do from my keyboard R. Again, a short key, R means rotate. So I can do it that way also, right? Now I have to place a pin for VDD and VSS. So VDD and VSS, they are going to be input output pin, because if you see in a network, the supply comes in and then it leaves. So that's why we keep VDD and VSS as input output pins, right? So I have connected here, put. So now let me give one more name, VSS. Yes. Now I can select wire W and I'll connect it over here. Right. Now, once you do that, right, so this is the console window on the right side. So it's saying some kind of error. We'll see. So just this. Now, before proceeding to the next step, I have to check whether all the connections have been made or not. So for that, I click onto this check and save, right? And the information whether everything is okay will be coming up in this console window. So here you have all the information whether it is coming correctly. So let me show this to you. Let's just do this. Let's just not connect this. Okay. I have deleted this particular wire and let's do check and save. So if you see, it is showing me here that there are zero errors, but there is one warning, right? So warning is there, and even on the schematic schematic window also, it is blinking. So that means it has not been connected, right? So what is the warning? Floating input pins. The input pin in is floating. So we should check this properly. So now what I do is I reconnect it. So again I press W and I'll connect it, right? And again I do check and save. And now if you see, it is not throwing me any warning issues as of now, right? So it has been passed, right? Now, so you have to be very very careful when you do that. So you can just check here also, right? So let's just delete this one and let's see what happens if I do check, right? Again it will show me the problem that there is a warning here, right? So I'll just reconnect this. Okay. Now another thing, if you want, so yeah, so now one thing is that how do we bring the MOSFETs here from the technology file, then how to connect them through a wire. So now let us suppose I want to change the width of my transistors, right? So for that what do I do is I select one of the transistor and I press Q. Okay, so Q. Here you will get what is known as a property editor, right? In the property editor, you can change the width. So the total width, I can make it as 1 micron, and this is my 40 nanometer, right? Now just see if I try to decrease it, yeah, it automatically changes it to 40 nanometer. So that means we cannot give a value less than 40 nanometer here, right? So, and after doing these changes, I will just do check and save. So if you see now, W is 1 micrometer, right? Similarly, if I do for NMOS, I just click because now the property editor is already open, and I click here. I can also make it as 1 micrometer, right? Yeah. So now we do check and save, and now our schematic part is done. So this is how we make schematic here, right? You can make any schematic which you want, right? In the next session, we will see how to make a symbol. Thank you.